Our first speaker is Alan Moran. He is an economist from Australia. I met him on my tour of Australia that I mentioned to you earlier this morning. He's with a public affairs group. He is at one time was an economist with the Australian government. He's now gone straight and works with a think tank, and he has recently written an understandable book on climate change, kind of just the facts. And I think we're all going to enjoy listening to Alan.
Thanks, Jay. Thanks very much. It's great to get the applause first because I might not get any after the speech. But let me just start off by saying that the IPCC argues that to prevent temperature increases greater than 3 degrees centigrade requires no growth in the annual level of global emissions. And what that actually means is that because of population growth, emissions would be required to be by 2050 at about 3.42 tons, which is the purple line there, compared to 4.54 tons today. And as you can see, the developed countries in the world are at like 20 tons, a bit less for the Europeans. But even now, China is at almost 5 tons at the present time, and of course China's only got about 20% of its people at near first world standards. India is well below still, but then again India has got a very high proportion, about half its households still don't even have electricity. So that's the scale of the task, to get down to that, according to the IPCC, get down to that level from these sorts of levels. The IPCC itself has a great many projections showing how its targets could be reached. This is just one of the tables, and it actually refers to them as storylines and scenarios. There's about 40 of them. This one actually shows that according to the IPCC, even with no tax, we'd see a 5 to 14% reduction in emissions. If we get a tax of $50 a ton, that will go to in the range of 13 to 52%, and $100 a ton would take us to in the range of 16 to 63%. So the storyline is that at a price of $50 a ton of CO2, or perhaps even $100 a ton of CO2, we can reduce emissions and stabilize temperatures on a global basis. $50 a ton, of course, means doubling the cost of electricity, and for it to bring about the abatement requires quite bold assumptions, I think, involving the energy substitutes and supply flexibilities. This chart you can't see, but I'm only putting it on because to baffle everybody. McKinsey's have done charts like this for every country in the world. Basically, it shows us a lot of free goods around here, if only people weren't so stupid, that we would actually reduce emissions and save by doing all those on the left-hand part of the screen, and those on the right-hand part of the screen we would save also, but at a cost, at a relatively low cost. So basically, what, for instance, it says is that if we went to tillage and residue management, there would be a saving. There'd be a saving of about 40 euros per ton of CO2. So it would be a negative cost of waste recycling. Similarly, nuclear power is a cost, a modest cost of about $10. One of the few things which is relatively uncontroversial there. Much of this is derived from much of the thinking in the IPCC is derived from these bottom-up type studies of McKinsey's and others, and it's as I say, the ones on the left are this fabled win-win situation. But there are some pitfalls in uncritically accepting these theoretical savings, and these have been illustrated by a number of practical measures. One of which is Australia, where we introduced a program on retrofitting of ceiling insulation, which McKinsey actually estimated has got a saving somewhere around there, quite a lot, big saving, negative cost. The Australian government wasn't naive to say it's going to be a negative cost, but it said it would be a relatively small cost, would save 50 million tons of CO2 at a cost of $2.5 billion. But in fact, the over-hasty and now discontinued rollout led to 4 deaths of contractors and over 100 house fires, and the estimated 50 million tons of saving is now considered more like 20 million tons, and the need to actually go back and unravel a lot of the work meant that the cost rose from about $50 per ton of CO2 theoretically saved to something like $200 a ton of CO2. And Australia, like every other country, has got a lot of war stories in terms of these sorts of programs. The Auditor General in Australia counted 550 individual programs for greenhouse gas savings, one of which, and almost every country's got this, was photovoltaic, household photovoltaic mechanisms. The Auditor General estimated that they cost $1 billion, around $447 per ton of CO2. Extremely expensive way of doing things. So, all that said, the key issue for economics is, if there is human-induced climate change, then the issue is, how much is this likely to cost? And how much would it cost to prevent it? Well, first of all, how much is it likely to cost? The most extreme estimate of global costs, if global warming takes place, is 12.5% of world GDP, which is the estimate there from the Stern Review. That's actually several times every other estimate. Richard Toll put together about 12 or 13 different estimates that have been undertaken, and they're all in the range of plus 2.5 degrees centigrade as a cost, or minus 2.5 degrees, that sort of area. And all of these are reputable and in the sense that they're, quote, peer-reviewed, unquote. But actually, all of these estimates are basically done by economists who just take the science as given, and they more or less accept the costs of the doom-laden aspects of scientific notions. There's most of the public statements on costs of warming harp on about things like dengue fever and other long defeated diseases that could only show a resurrection, as Jay Lear said, actually, with DDT. It could only show a resurrection if we decided that we were going to ban DDT, as we have, which is allowed to resurrect malaria. And some of the now discredited cost elements are associated with the intensification of hurricanes, or lower production of food in Africa, even things like the reduction of the coastal areas, inundation of coastal areas. Even the IPCC has tended to downplay that somewhat in its more recent report. So the cost benefit, the costs of the global warming are, relatively, even at the most, the subjects are, it would cost the world plus 2 or minus 2.5% of GDP. I mean, that's not insignificant, not insignificant at all. But let's just put it in the context of where the world is going. This is based on IMF data about projecting forward income levels, world income levels, over the next century, or almost a century. And what they show is that the world on average is likely to grow by about 900%. India and China far faster than that, as they approach, on these estimates, something like the first world income levels, and the first world areas themselves growing, 2 or 3-fold. So what we're actually talking about is a cost which, even on doom-laden forecasts, is about 2.5% of GDP at most, in the context of world GDP growing many, many times more than that, perhaps 900%. So, the actual, in that sense, the actual cost of global warming, even on the adverse assumptions being made, is quite trivial. So that's really the cost. But what are the costs of preventing it? Well, the IPCC has got that covered too. According to the modelers and the promoters of greenhouse curtailing measures, these costs are also low. The IPCC puts the cost at around 5% of GDP. That is of reducing the emissions by the quite colossal amounts that we have been talking about. Using a similar methodology, the economic modelling sponsored by the Australian Treasury puts Australia's cumulative costs of cutting, in Australia's case, 4/5 of current CO2 emissions at 2 or to 3% of GDP over the course of the next 50 years. These unbelievably low costs emerge from carbon taxes that at least treble the cost of electricity, even if the anticipated low-carbon energy innovations, which are within the models, even if they prove to be practical. Now, those sorts of conclusions draw upon the experience of rapid adjustments, which we've seen in response to different shocks or different policy changes over the years, like tariff reductions or like privatization, major changes in economies. These major changes have largely brought increases in the analysis. But of course, the new taxes would not bring an increase, and nobody suggests it would bring an increase in efficiency or in terms of measured GDP. But many argue that they are low like that for a whole stack of reasons. These hefty carbon taxes, they say, would mean little relocation of industry, in part because most of the costs of industry are relatively small to most industries, and because many of the costs are sunk. But this kind of analytical framework, which is the basis of all the cost estimates done by IPCC and our various national bodies, is based on very serious shortcomings. Optimism about future adjustments misunderstands the nature of commercial decision-making. Adjustment pressures cannot be assessed by estimating the average cost faced by an industry as a whole. The location decision of an industry is taken by a firm's shareholders, and they receive the residual reward, which we call the profits or the losses from failures. So let me just say we say, well, overall, the cost might rise by only 2%. Plausible, possible. But if a firm has 10% of its revenue as profits, it's that 10% that's driving it. So 2% of 10% is actually a 20% reduction in its revenue to its shareholders, so that we have an amplification of the aggregate costs that drives this decision. And we can see the effects of some of that in contemporary issues, for example, in Asia, with the relocations of sportswear manufacturers, etc., in response to quite small changes in the costs between different countries. So looking at aggregate industry costs seriously underestimates the dynamics of change in response to cost shocks. But many economists actually compound that mistaken analysis by promoting a vast new edifice of regulatory measures to manage the effects of the changes they propose, in order to prevent distortions resulting from firms that are export-oriented or vulnerable to import competition from foreign firms that don't have the tax impost. The Australia's Garner report and the economist Joseph Stiglitz, the head of the WTO, Pascal Lamy, advocate a system of export compensation and border taxes. Now, it's easy to see how this could bring about serious repercussions in the entire world trading system. Moreover, the bureaucracy to check the costs of thousands of firms and their markets and the cost of their competitors and the responsiveness of consumers to increase prices from the carbon impost would bring a level of intervention never seen before in developed countries. The problem with forecasts stretching out into the future is that the models that they use are built to estimate quite small changes over relatively short periods. So we can accurately model changes throughout the economy, say a coal price increase of 10%. 10% increase in coal price, we'd see some shift to other energy sources, we'd see which have costs below that, we'd see some change in the end-use products, those using coal would tend to decline, and we'd see some expansion of demand from products that use less coal and less energy. All of these would tend to offset somewhat the initial loss caused by the increased costs. We've also got a great deal of experience in major changes in the oil supply, or at least some experience. During the 1970s, we saw oil increase or quadruple in price. And of course, this caused considerable economic dislocation, but adjustments were made by finding ways to economize on oil. and these included substitutions by coal and natural gas, nuclear, and the higher prices of oil also brought about some increased oil discoveries. But a tax on carbon is far wider than this. There are few offsetting effects available. If we can kind of visualize this best by imagining the food sector. If there was a tax, a very high tax on oranges, indeed all citrus fruits, that drove out the entire production of that class, people would actually migrate, would choose alternative goods, and there'd be some modest, perhaps even major, but nonetheless easily acceptable loss of income. But now substitute that for a tax on the whole of food. There'd obviously be mass starvation. Essentially, carbon abatement means eliminating 80% plus of existing sources of energy. In order to accommodate energy needs in a near carbonless world which is being projected, modelers have made very courageous forecasts about new sources of energy. Australia is pretty much the same as every other country. And the great thing about this chart is that the top three, the blue, the green, and the orange, are where we will be in the future. None of those have been discovered yet. None of them have been used. The top three are carbon capture and storage for gas, carbon capture and storage for coal. Doesn't exist. There's $2 billion a year being put into this in Europe and in the US. Nobody can do it still. And the non-hydro renewables, which of course we've heard and we'll hear more, are really not an option in the future. Of the known sources, only nuclear is available as a carbon-free alternative, and this, perhaps because of excessive regulation, is dearer than fossil fuels in most countries. It's also difficult to envisage it being used for a lot of the transport tasks. Nuclear is also rejected by most of the decision makers who are in favour of abatement. And one of the aspects of forcing the abandonment of coal or another hydrocarbons is a forced loss of wealth. In Australia's case, we've got about 8% of the world's coal. That's valued in the ground at far more than the national GDP. Let me make a few concluding comments. The economics of abating the cost of greenhouse is not understood. The various models do use Pollyanna-ish aspects, Pollyanna-ish forecasts. Most governments are actually already, and these are Australia's, but most governments are doing this pretty much the same. They're already incurring a great deal of cost. There's budgetary expenditures on demonstration projects, energy reduction programs and the like. In Australia's case, that's about $3 billion a year. There's regulations on appliances and other uses that force up prices. A big one in Australia and probably most other countries is forced energy savings on new houses. They had about $7,000 for the cost of a new house in Australia. And then there's the regulatory requirements that apply a hidden tax on consumers to force the high-cost renewables by requiring a certain mix of the renewables in the energy retailer's mix of products. Wind power, we've heard, is at least twice, and for Australia, it's 3 times the cost of conventional energy. We've seen very big increases in wind power over the past few years. Spain, we heard, has got about 12% of its electricity, and it may have wrecked the country. It costs 2.2 jobs per every job created, about $1 billion as well for every job. Germany is also quite high. US about 2%, China about 1%. Fortunately, there now seems to be less enthusiasm to rush into the economic demise that was pending. If we look at the Copenhagen Accord, we can see here, plucky Australia is the only one giving an unconditional commitment of 5% reduction. But of course, that commitment has already been voted down by the Australian Parliament. It's still on our books as being in there. Everyone else has given conditional targets, but those conditional targets have got real strong caveats in them. For example, Japan's is premised on the establishment of a fair and effective international framework in which all major economies participate, and even the EU has its proviso that developed countries commit themselves and developing countries contribute adequately, etc. So Australia's unconditional is somewhat absurd, especially since we heard from Jay at breakfast that the government has now shelved its proposal to 2013 as at the very earliest. So what we can see, and I think that there is room for a lot of a lot of enthusiasm and optimism on our parts. What we can see is that there will not be a new international carbon tax. Absolutely out of the question. The economics has fallen prey to the reality of the costs involved. So it's now time to take the offensive, and I think we've got to think in terms of a variation of the peace dividend that occurred once the Soviet Union was overturned following the Cold War. That waste that was involved in armaments, etc., is similar to the waste that's been accompanied by the great climate scare over the past 15 years. And if we can unwind this, we'll offer a comparable ability to divert unproductive expenditure into consumption and investment. And that should be our next goal. Thank you.